Hi friends, we are still in chapter 8 and what we're looking at is section 8.1. We're going to be talking about quadratic equations. The particular type of quadratic equations we're going to talk about are in, let me see if I can get a pen, are in this form here where we have x squared plus bx plus c equals 0. But as our definition here tells us, quadratic equation is an equation that's in the form where you can have ax squared plus bx plus c equals 0, where a, b, and c are all elements of the rational numbers, okay? So that keeps it as a quadratic polynomial. For most of the problems that we do, a, b, and c will all be elements of the integers. So they should be integer coefficients. So the thing about a is that a has one more restriction. A cannot equal 0. And it totally makes sense if you think about if a were equal to 0, then that would be 0x squared. And then you'd lose your x squared term because 0 times anything is 0. And so you'd be left with bx plus c. Technically, you would have a linear equation, right? A line, so the only thing you have is like an x term and not an x squared term, and that would change the fact that you don't have that would make sure that you did not have a quadratic equation. So to ensure that we do have a quadratic equation, when we define it like this, we say a also cannot equal 0. The other guys can equal 0, but we need that squared term in order to have a quadratic equation. This next problem is really giving us a chance to factor. Now, factoring, what I'm thinking about, this is a thought bubble, you don't have to write it down. Factoring is going in the opposite direction. Factoring a trinomial is going in the opposite direction of what we did before when we were multiplying binomials to get a trinomial. So if you remember, if I had like x plus 7 times, I don't know, x plus 5, and I asked you to multiply this, you would say, oh, I'm going to do the first two, the outer two, then the inner two, and then the last two, because you would have to have a British accent to do that. That's what I was trying to go for. Okay, so anyway, x times x is x squared. X times that is plus 5x. 7 times that is plus a 7x. And then 7 times 5 is plus 35. And if you notice, these guys will come together to give me 12x plus 35. And the x squared is here. And that's pretty simple, right? But now what we're trying to do is undo this to get back to this. So what we have to do is think, okay, how do we get the x squared here? Because this is what we're starting off with. Well, we got x squared because of the x in the first position of each of the binomial spaces. How do we get the 35? We got it from the 7 and the 5. How did we get the 12x in the center? It was from adding the 7 and the 5 once we multiplied it with the x's, and we ended up getting 12x. So with that knowledge, we're going to actually try to apply it to this problem. So the first thing that we see is, yes, we're going to be multiplying two binomials. That's what we expect when we have a trinomial. A quadratic trinomial, we're going to try to factor it. So we would expect that we have an x here and an x here. The next thing we need to do is think about the factors of 20. The factors, or factor pairs of 20, actually. So I have 1 and 20. I have 2 and 10. I have 4 and 5. And of course, I can switch the direction, but right now we don't actually need to do that. I could talk about it as 20 and 1, 10 and 2, so forth and so on. But I don't need to do that. So now what I need to do is think about what pair of numbers multiply like 7 and 5 did to give me 35, yet add up to give me 12 in the center. And so when I look at this, not 12 in the center, here 9x in the center, 9 in the center. So 1 times 20 is 20, that works, but it doesn't work for the 9. 2 times 10 is 20, but it doesn't work for the 9. It's the 4 times 5. So then I put in my plus 4 and I put in my plus 5 because I'm trying to find two numbers that multiply to give me a positive 20, yet add up to a positive 9. Does that make sense? So I feel confident that I factored correctly. I'm going to check it. X times x gives me x squared. X times 5 gives me a plus 5x. 4 times x gives me a plus 4x. And then 4 times 5 gives me a 20. And I see that all is well in my factoring kingdom. All right, so I'm feeling pretty good about this. But this rule, what we did here, only works when a is equal to 1 and b and c are positive. So when I say it only works that easily. So I want you to pay attention to the next couple of examples so you can see how we're going to kind of adjust some of our thinking around this factoring. So here, we still have A is 1, but B is negative and C is positive. So let's think about what this means. We know that when we multiply these two binomials, we recognize that we're going to have an x here and an x here. And the reason why is because these two x's are going to get together to make this x squared. But now what I see is that I get a positive 12 here, but they're going to add up to a negative 8. How can you get two numbers that multiply to give you a positive but yet add up to a negative? I hope you're thinking about this, and I hope you're saying, it doesn't happen. No, I'm just kidding. I hope you're saying, obviously, the two numbers that multiply to give me a positive 12 must both be negative so that they add up to give me a negative 8. So when I'm thinking about factors that are going to give me a positive 12, I'm thinking about not 1 and 12, but negative 1 and negative 12. I'm thinking about negative 2 and negative 6. I'm thinking about negative 3 and negative 4. And the reason why, notice this told me that the signs have to be the same, but this told me what those signs are going to be, and both of them are going to be negative, all right? So signs the same, negative. I'm going to slide back to the last problem. Signs the same, but both of them are positive. All right, so let's see how this works out. So I'm looking for two numbers that multiply to give me 12, yet add up to negative 8. I think you probably already deduced that that's going to be this guy. So that pair, I should say. So I have negative 2 minus 6, and I'm going to multiply to check, make sure I'm on the right page. X times x is x squared. X times a negative 6 is a negative 6x. Negative 2 times x gives me a negative 2x. Negative 2 times a negative 6 gives me a positive 12. And I'm feeling pretty chummy about myself right now because I got it right and I like what I'm doing, right? So this is nice. So this is what we do. This is the answer we're looking for. The check was just for us. I'm not requiring you to check. All right. So now here we have a different situation. Now the C term is negative, right? The C term is negative. So what does this mean again? Let's think about it. I'm going to do this first part. We can call this one part A. I'm going to factor it. I know that both numbers need to multiply to give me a negative 15. How do I get two numbers to multiply to give me a negative? One has to be positive and one has to be negative. And then those two numbers need to add up to a positive 2. So two numbers that multiply to give me negative 15 yet add up to a positive 2. Well, let's think about the list. So I could have a positive 3 and a negative 5, or a negative 3 and a positive 5, or a positive 15 and a negative, no, positive 15 and a negative 1, or negative 1 and a no, that's the same thing, or positive 1 and a negative 15. So I think I have all the possible pairs. Now I'm going to ask myself again, what two numbers can multiply to give me that negative 15, yet add up to give me a positive 2. And yes, it's staring us in the face. It's going to be negative 3 and 5, because a negative 3 plus 5 is a positive 2, not 3 and negative 5, all right? So my x's are here just as I'm used to. My negative 15 will be accommodated by the minus 3 and the positive 5 that I have here. And I'm going to add these guys up and check. And so basically, I know x times x gives me x squared. I know negative 3 times negative 5 gives me x here. So I know the first two work, right? I know the last two work. But really what I want to check out is I've seen me using the memory device FOIL, F-O-I-L. I know the F is working, L is working. I need to check out the O and the I. And the O and the I can be checked like this. So I do negative 3x, and then 5 times x gives me 5x. When I add them together, I get 2x. So I feel confident that what I did worked. Notice I did not do the whole FOIL method here. I compensated for doing that by just doing the part that I was concerned about to make sure that the 2x worked. All right, I know I said a lot, but I'm hoping this is making sense. Let's go ahead and look at this next one. So we know that to get the x squared, I'm going to get the x here on both parts, on both parts of this both of these binomials. Sorry, people. And then I have a negative 18. And how can I get a negative 18? I know the signs must be different. So I'm looking at 2 and 9. I'm looking, or negative 2 and negative 2 and positive 9, a positive 2 and negative 9, positive 3 and negative 6, or 6 and a negative 3. So I think those, and of course I could do 18 and 1, and I'm sure there's one that I'm not thinking about. So I'm looking at these pairs, and when I look at them, I'd say, oh, well, 2 plus a negative 9 is going to give me that negative 7. So I have a plus 2 and a minus 9. No, it doesn't matter if I did minus 9 plus 2 as long as they carried the proper sign. And I'm going to do a double V to check my center term. So I've got 2 times x gives me 2x. Negative 9 times x gives me a negative 9x. And when I'm done, I get the positive 7x. So I feel cool because I know that x and the x gives me x squared. 2 and a negative 9 gives me negative 18. And I'm feeling good about my factoring skills. Let's go ahead and take a look at another one. I hope we have time for the whole video. I don't want to have to do a part 2, but let's see what we can do. All right, so example 4, solve an equation by factoring. So now this is an equation. Again, I want to point out, when you have an inequality, notice there's no equal sign up in here. You are only being asked to factor. You don't have to solve anything. But when you have an equal sign, oftentimes you are asked to solve. You can only solve if there's an equal sign. You need to have an equation to solve, okay? All right, so I'll get that out of the way. So when we solve these guys, it's really important to bring everything over to one side so that you have it in ax squared plus bx plus c equals 0 form, okay? That's the one thing. So I've got x squared plus bx minus 27 is equal to 0. The next thing I'm going to do is factor this side, and we just had wonderful examples of factoring, so we're going to apply that here. I know that x times x gives me x squared. I need to find two numbers that are going to multiply to give me a negative 27, yet add up to a positive 6. So I can come over to the corner and start writing down numbers. 9 and 3 would give me positive, but oh yeah, 9 and 3, look at that. But what do the signs have to be on my 9 and 3? Which one's positive, which one's negative? Hopefully you realize that the 3 has to be negative, right? I want a negative 27. And the reason why is because 9 plus a negative 3 gives me that positive 6. So I rock a positive 9 here and a negative 3 here. Do my double V really quickly to check. I got my 9x. I got my negative 3x. All together, that gives me a positive 6x. All right, feeling good about myself. So the next thing that I'm going to do, right, check this out. I think you will love it. Okay, maybe not. I think you will sort of respect it. There we go. Is I'm going to apply that rule. Do you remember that property we talked about? If A times B is equal to 0, then A is equal to 0, or B is equal to 0. You remember that? Well, we're doing that right now. If blah times blah is equal to 0, then either x plus 9 equals 0, or x minus 3 equals 0. So we are about to get solving. So now I'm just going to subtract 9 on both sides of this portion, or this equation, and I'll get that x is equal to a negative 9. And then I'm going to add 3 to both sides of this equation, and I get that x is equal to a positive 3. Voila! There are my two solutions to that problem. I like that. I hope you did too. Okay, so this brings us to example 5. The area of a poster board is given as 616 square inches, and its dimensions are W by W plus 6. Anytime we have a problem like this, it always makes sense to draw a picture, so we're going to do that. Here's our poster board. Voila. We know that the area is equal to 616 inches quantity squared, or inches unit squared in that case, because we're talking about little tiny squares. And what we know is that the dimensions are W by W plus 6. So what we need to do is find W. Well, what we're going to do is use our brains. So we're going to figure out, well, we know that length times width is going to give me area. So I need to multiply the length and the width here. So the area is equal to W times W plus 6, which we know to be 616. I'm going to distribute, get W squared plus 6W is equal to 616. Well, what do you know? We've got a quadratic equation. Let's solve it the way we were taught to. W squared plus 6W is minus 616 is equal to 0. Now what we need to do is figure out the factors that we can have of 616 that will that multiply to give me two numbers that multiply to give me 616 but add up to give me a positive 6. Now what I hope you see is that since this is a negative, the signs are going to be different of the two factors that we're talking about. And so if I'm looking for two numbers, so I can restate this, I'm looking for two numbers that multiply to give me 616, yet subtract to give me a positive 6. All right, so I want you to think about that, and I'm going to be back with the answer in just a second. Okay, after sitting here and thinking about this for a while, I realized that 28 times 22 multiplied to give me 616. No, that was not at the back of my mind. I did not have it there. So sometimes you got to work through it and kind of think about it. And the difference, if you notice, the difference between 28 and 22 is that 6. So I'm going to pause again and give you the answer. Hold on. So first we can factor it like this. Now we're going to set each of these equal to 0, and our answers are W equals either negative 28 or positive 22. We're going to reject the negative because we're talking about real life. Oh no.